Okay, I'm going to talk about standard form. So this is an equation given to you on your formula sheet. We're going to talk about when you graph, you really just need two pieces of information. That's your vertex and your slope. Okay, so the vertex is going to be the point H, K. So the H is the one that connects with the X, K is the one that connects with the Y. So you can remember it in that order, right? Because X comes before Y, H comes before K. You can also see that in my formula, I'm presented with a negative H and a negative K, and then my vertex has a positive H and K, so they're going to be opposite values. And the slope is the A value. So what does the slope tell you? If it's positive, it will go up. If it's negative, it will go down. If it's a big number, it will go skinnier, right? A fraction number, it will go widen itself out. So that's what the slope tells me. So it tells me either it's up or down, or it tells me the width, what's the rate of going up. Okay, so let's look at an example. Y minus 2 equals x plus 3 squared. Okay, so vertex is the opposite, so negative 3, positive 2. And the slope is, what's the multiplier in front? 1. Okay, so negative 3, positive 2. Is right here. Okay, now I'm going to do a basic pattern because my slope is 1. When the slope is 1, it tells me to go over 1, up 1, over 2, up 4, over 3, up 9. Okay, you remember that from learning about the basic quadratic? Okay, so I'm going to go over 1, up 1, over 1, up 1 the other way. I'm going to go over 2, so from the vertex, go 1, 2, and up 4. 1, 2, 3, 4. Over 2, up 4. And that's my quadratic parabola graphed. Okay, so now let's ask ourselves a few things. I'm going to get you to do the axis of symmetry. Okay, so the axis of symmetry would be that near, you can see that I could flip my parabola over that line, right? Okay, so this vertical line is an x equals line, and the x value is negative 3. So you can see that the answer to this is always going to be x equals whatever your vertex value is right here, your h value. Okay, now I might ask you, what is the domain and the range? Okay, so domain is all of the x values, so this keeps going and going and going that way, and going and going and going that way, right? So the domain for every parabola, if it doesn't have restrictions, it's going to be from negative infinity to infinity. So what is the range? All of the y's. So what's the lowest to highest? So the lowest it is the height of 2, and then forever up. So we're going to go from 2 to infinity. Okay, does this have a min or a max? So I'm going to ask you that. So this would be, the vertex is on the bottom, so it's a minimum, and the lowest it goes is 2. Okay, now I'm going to ask for y-intercept.
Can you get a custodian to the office, please? A custodian to the office.
So a y-intercept is where is it going to be on this line? So on this line, you should know that your x value is 0. Okay, so you're going to plug in 0. So I'm going to go y minus 2 equals 0 plus 3 squared. So you see I'm putting 0 in for my x. So 0 plus 3 is 3. 3 squared is 9. Then I'm going to add 2 and get 11. So now you can see that in your parabola, it's going to hit the y-intercept at 11, and that makes sense. Okay, so let's look at another one. So what if I do y equals negative x plus 5 squared? Okay, so vertex HK. So the H is opposite, so negative 5. And there's nothing there with the y. So then that means that my k value is 0. The slope is a negative 1. So that tells me I'm going to go my regular pattern. 1, 1, 2, 4, 3, 9, but this time I'm going to have these multiplied by negative 1. Okay, so let's graph that. 1, 2, 3, 4, 5, 0. And then I'm going to go like this. Over 1, down 1. Over 1, down 1. I'm going to go back to my vertex. I'm going to go over 2, down 4. Over 2, down 4. Okay. My axis of symmetry is the vertical line, x equals, and that's a negative 5. Domain is for all of them, that it goes left and right forever out. The range, what's the lowest to the highest? So the lowest is forever, keeps going, so negative infinity to the highest point, height of 0. So this would have a max of 0. So that's a top point is a maximum. And a y-intercept, let's do that. So y equals negative, and then I replace my x with a 0. So now let's go inside the brackets, 5 squared. And then 5 squared is 25 times by negative after. So this is going to keep going, 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 and then it's going to cross down there. And so that makes sense, right? Because if I got an answer of like positive 25, it wouldn't make sense because this parabola is going in this direction, right? Okay, next one. So this one is funny because it doesn't really look like y minus k equals a x plus or minus h squared. It doesn't look exactly like that. So what I'm going to do is I'm going to move this number to the other side. So if I move this, it would become a plus 3 over there. Okay, so now I can match everything up. My vertex is my hk, so negative 1, negative 3. My slope is 3. So what does that tell me? 1, 1, 2, 4, 3, 9 is going to change. I'm now going to go up 3 there, up 12, up 27. Okay, so start. -1, -3. So I'm going to go over 1, up 3. I'm going to go over 2, up 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is from my vertex over 2, up 12. So you can see that it got narrower. Okay, so then my axis of symmetry is the mirror line x equals -1. I'm going to flip my parabola around that. The domain goes forever left and right. The range, the lowest it goes is -3, and the highest it keeps going. So this has a minimum of -3. And my y-intercept, I'm going to go y equals 3 bracket 0 plus 1 squared minus 3. So that's the key piece, plugging in 0. So 3 times 1 squared minus 3. 3 times 1 squared is 3. 3 minus 3 equals 0. And that is also matching with my graph. It crosses that y-axis at a height of 0. Okay, that is standard form of quadratic equation.